Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Okay, think about this for a second. That amazing-looking game you were playing last weekend, or the operating system just running your computer right now, even spacecraft software.
Yeah, it's wild when you think about it.
They could all share this incredibly powerful foundation, and often that's C++A. It's this language known for just raw speed, control, power, really.
Absolutely. It's one of those technologies that's so fundamental you almost don't see it, but it's under the hood of so much of our digital world. Learning about it is kind of like getting the schematic for a really complex machine.
Exactly. So that's what this deep dive is all about. We've put together a journey right into the heart of C++A. Think of it as your way to really get a handle on this language, its history, what makes it tick, and why it's still so critical.
Right.
Our mission here is simple. Give you a clear picture of what C++ is, why it matters, without, drowning you in tech jargon.
And we pulled together some really great info that cuts right to the chase, how it evolved, what it can do, and its place today.
Okay, let's dig in then. Where did this powerhouse even come from, its origins?
Right, so the story really begins with its parent language, C, that was cooked up at Bell Labs way back in the 70s.
Well, go ahead, okay.
Yeah, and C was a real game changer. It was low level, meaning it could talk almost directly to the computer hardware.
Right down to the metal.
Exactly. But it was also portable, which was huge then. You could run it on different machines. It gave programmers direct access to memory, to hardware. Perfect for building things like operating systems, the real foundational stuff, like having direct access to a car's engine.
Okay, so C was the engine access, but then came the plus plus. What was the spark for that?
So fast forward to the early 80s. There's this brilliant guy, Yarny Strastrup.
Right, I know the name.
He had this thought. What if you could take C's speed, that low-level power, but combine it with better ways to structure code, like using classes, objects, ways to model real-world things more easily. Abstraction, basically.
Bringing organization to the raw speed. Interesting.
Precisely. That was the core idea. In fact, its very first name was literally C with classes.
Huh. Tells you exactly what it was trying to do.
It really does. And then, over time it grew, got more features, and eventually got that catchier name, C++ Air.
And the name itself, that's a bit of an inside joke for programmers, isn't it?
It is. In C, and also in C++, the plus plus operator means increment this value by 1. So C++ is basically a little nod, meaning C, but the next step up, an improvement.
I like that. Very clever. Okay, origin story. Check. Born from C, aiming for speed plus structure. So what is C++ today, in simple terms?
Okay, fundamentally, it's a compiled, statically typed, general-purpose language.
Let's break that down. Compiled.
Compiled means your C++ code gets translated directly into the machine's native language, the actual ones and zeros the processor understands before you run the program.
Okay, translate first.
Yeah. And that's a huge reason why C++ is so fast. There's no middleman, like an interpreter or a virtual machine, slowing things down while it's running. It's just native code.
Got it. Straight to the processor. And statically typed? What's that about?
Statically typed means when you write the code, you have to declare the type of data each variable will hold. Is it a number? Is it text?
You have to specify up front.
Exactly. And the compiler checks that you're using them correctly before you even try to run it. It catches a lot of potential mistakes early on. Think of it like spell checking your document before you hit print, not finding typos while you're reading the printout.
Okay, so compiled for speed, statically typed for early error catching. What else makes it unique?
Well, the close to the metal capability is a big one. It lets developers directly manage the computer's memory using things called pointers.
Pointers. I've heard those can be tricky.
They can be, yeah. Think of them like direct addresses to memory locations. It allows for really precise control over hardware. Then there's its multi-paradigm support. It's not just one style of programming. It's famous for object-oriented programming building with components like Lego bricks.
Right.
But it also supports straightforward procedural programming, step-by-step instructions, generic programming, writing code that works with different data types, even some functional programming concepts, more mathematical style. It's like having a really versatile toolkit.
So it's flexible in how you approach building software.
Very flexible.
Yeah.
But maybe its most defining feature, and sometimes its biggest challenge, is manual memory management.
Ah, okay. Tell me about that.
Unlike a lot of newer languages that have automatic garbage collection to clean up memory you're done with.
Right, like Java or Python handle that for you.
Exactly. In C++ Bell, the programmer is responsible. You have to explicitly ask for memory when you need it. And crucially, you have to explicitly release it back when you're finished.
So you're in charge of cleaning up after yourself.
Pretty much. This gives you incredible power over performance and how resources are used.
Oh,
But it also means if you forget to free memory, you get memory leaks. Your program eats up more and more memory.
which is bad.
Very bad. Or worse, if you try to use memory after you've freed it. That can cause crashes or unpredictable behavior. Security issues even.
Sounds like a double-edged sword. Huge power, huge responsibility.
That's a perfect way to put it. Now, we've talked about what it is,
Sure.
but maybe seeing where it's used makes it more concrete.
Absolutely. Let's talk applications. Where do we see C++ in action? I know games are a big one.
Oh, huge. Game development is C++ territory. Think major engines. Unreal Engine, CryEngine, Source Engine.
The big ones.
They're built with C++. Why? Performance, just sheer speed. In games, every single frame on screen, every physics calculation has to happen incredibly fast, fractions of a second.
Milliseconds count.
Exactly. C++ lets developers squeeze every drop of performance out of the hardware, optimize everything right down to the metal. You just don't get that level of control easily with many other languages.
Makes total sense for something as demanding as modern games. Okay, what about the software that runs our actual computers? Operating systems.
Another core area. Large parts of Windows, Mac OS, Linux, they rely heavily on C++.
Really? Which parts?
Think about device drivers. The software that lets your OS talk to your graphics card or your network card. File systems, managing how data is stored. These are places where you need maximum efficiency and direct hardware access. C++ is perfect for that.
Wow, so it's literally foundational to our everyday computing. That's quite something. Where else?
Embedded systems, those little computers inside everything now.
Like in cars or smart devices.
Exactly. Cars are a great example. The engine control units, the ECUs managing the engine, anti-lock brakes, infotainment systems, often C++ Zen. You need high performance, but often with very limited power and memory. C++ gives you that control. Same for lots of IoT devices, medical equipment, industrial controllers.
Right, where efficiency and direct hardware control are absolutely critical.
Totally. And that need for speed takes us to another extreme. Finance, specifically high-frequency trading.
Ah, the HFT systems. Making trades in microseconds.
Even faster sometimes.
Yeah.
Nanoseconds, a billionth of a second. In that world, C++ is king because executing trades fractionally faster than the competition can mean big money. The latency has to be incredibly low.
Nanoseconds. It's hard to even wrap your head around that kind of speed. Okay, any other maybe surprising places?
How about your web browser?
My browser. Like Chrome or Firefox.
Yep. Core parts of them use C++. Google Chrome's V8 JavaScript engine. The thing that runs all the interactive bits on websites has a C++ core. Parts of Firefox's rendering engine, the part that actually draws the web page on your screen. Even Safari. Performance-critical sections often rely on C++ raw.
So even browsing the web, C++ is working behind the scenes for speed. What about more specialized areas? Science, robotics.
Definitely. Robotics relies heavily on C++ for the precise, real-time control needed for robot arms, drones, autonomous vehicles. Physics engines used in simulations and games often use C++ for accurate, fast calculations.
Makes sense.
And in scientific computing, handling massive data sets and complex calculations. Libraries like Root, used at CERN for particle physics data, or DEAL2 for complex simulations, they're often C++ because of the efficiency needed.
It's just incredible. The sheer breadth of use is amazing. From games to finance to science to the device in your pocket. So, okay, let's talk strengths. What keeps C++ so dominant in these demanding fields?
Well, the strengths really tie back to what we've discussed. Number one, clearly, is that unmatched performance.
The speed.
The speed. Because it compiles to native machine code, it's just incredibly fast. Essential for anything time-critical.
Okay, performance is key.
The full control aspect. Developers get really fine-grained control over memory, how the program runs, how to optimize it for specific hardware. You can tweak things at a very low level.
Right, the close to the metal idea again.
Exactly. Portability is another big one.
Yeah.
You write C++ code, and you can generally compile and run it on a huge range of platforms. Windows, Mac, Linux, embedded systems, supercomputers.
Write once, run almost anywhere with compilation.
Pretty much, yeah. And don't forget the ecosystem. C++ has been around for decades.
Right. It's mature.
Very mature.
Yeah.
There's a massive collection of powerful, well-tested libraries and frameworks. Things like Boost for general utilities, Qt for user interfaces, OpenCV for computer vision, OpenGL for graphics. These save developers tons of time.
A huge head start with existing tools.
Absolutely. And finally, that static typing we mentioned earlier. Catching errors at compile time really helps build more robust, reliable software in the long run. Fewer surprises when the program is actually running.
So speed, control, portability, a rich ecosystem, and early error detection. That's a powerful combination. But nothing's perfect. We hinted at the downsides earlier. Let's talk about the challenges.
Yeah, the biggest one, no question, is this steep learning curve.
It's known for being tough to learn.
It really is. Concepts like pointers, references, understanding the stack versus the heap for memory, weird issues like object slicing, undefined behavior, these can be really challenging for beginners. It demands a deeper understanding of how computers actually work.
You really need to get under the hood.
You do. And that manual memory management we talked about, a huge source of potential bugs.
The memory leaks and what was the other one?
Use after free. Try to use memory you've already given back. Both can lead to crashes, weird behavior, security holes, and they can be really hard to track down sometimes.
Subtle bugs that bite you later? Classic.
Exactly. And when things go wrong, especially with more advanced features like templates, the error messages the C++ compiler spits out can be notoriously long and confusing.
Pages of errors for one small typo.
Sometimes it feels like that, yeah. Even for experienced devs. It can also feel a bit verbose. You might need to write more lines of code in C++ to do what you could do more concisely in, say, Python.
More boilerplate sometimes.
Sometimes, yeah. And finally, because it has such a long history and values backwards compatibility, it does carry some legacy baggage. Older ways of doing things that maybe aren't as clean or modern as you'd find in newer languages.
Okay, so steep curve, memory pitfalls, potentially cryptic errors, verbosity, and some historical baggage. It demands a lot from the developer.
It definitely demands care and expertise.
So given all that, and with newer languages like Rust gaining traction, promising performance with safety, the big question, is C++ still relevant heading into 2025 and beyond?
Oh, absolutely. 100% relevant. It's not going anywhere anytime soon.
Still a cornerstone.
Definitely. Look at all the critical systems we just talked about. Games, OS, finance, embedded. There isn't really another single language right now that hits that same sweet spot of raw performance and that level of low-level control that these domains require.
So even with languages like Rust emerging.
Rust is fantastic, don't get me wrong. It offers amazing safety guarantees, which is a huge plus. But C++ has decades of momentum.
Yeah.
Trillions of lines of existing code run the world. Rewriting all that is just not practical.
The inertia is massive.
Huge. Plus, C++ isn't standing still. It's constantly evolving. New standards come out every few years.
Yeah.
C++ 20, C++ 23, C++ 26 is on the way. They add modern features, improve safety, make it easier to use, often without sacrificing that core performance. It's adapting.
So it's not a dinosaur. It's actively improving itself.
Exactly. In its core areas, systems programming, performance-critical applications, it's still the king. It truly remains the language of systems.
The language of systems. I like that. Okay, so final question then. Who should actually bite the bullet and learn C++ ball? Who benefits most from tackling that learning curve?
Well, if you're passionate about making video games, especially working on the engines themselves, C++ is pretty much essential.
Game dev hopefuls, take note.
Definitely. Same if you dream of working on operating systems or writing compilers or other really fundamental software tools.
Low-level systems work.
Precisely. Also, anyone getting into robotics, embedded systems where you're controlling hardware directly, or high-performance scientific computing, C++ skills are incredibly valuable there.
So people who want to work right at the software-hardware boundary or where performance is absolutely paramount.
That's the heart of it. And honestly, even if you don't plan to use C++ every day, learning it gives you such a deep understanding of how computers really work, how memory is managed, how programs execute. It makes you a better programmer, even in higher-level languages, because you understand what's happening underneath.
It provides that foundational knowledge.
Exactly. It's a challenge, no doubt. It takes dedication. But the payoff, in terms of capability and understanding, is immense. It really can set you apart as a serious systems-level developer.
Okay, so wrapping this up. C++ sounds like this incredibly powerful, enduring language, a real veteran, absolutely vital for top performance and control. but yeah, complex and demands real mastery.
That sums it up nicely. It demands respect, careful handling,
Yeah.
but in the right hands, it's an incredibly potent tool, almost like a precision instrument or maybe even a weapon in the coding world.
A weapon. That's strong. Okay, here's something for you, the listener, to think about. Just consider how much of the tech you use every single day. Games, your phone's OS, the browser you're maybe using right now, parts of the internet itself, how much of it fundamentally relies on C++.
It's everywhere when you start looking.
Maybe think about which application we discussed today really caught your interest. Was it the game engines, the embedded systems, high-frequency trading? Perhaps that's an area worth exploring a bit more, digging into how C++ makes that specific thing possible. It might even spark an interest in systems programming you didn't know you had.
That's a great takeaway. Always keep exploring, always keep learning. The world of code is vast, and understanding these foundational pieces is incredibly rewarding.
Couldn't agree more. Thanks for taking this deep dive with us today. Until next time, keep learning.